Welcome to Industry Ignited, the show where we spotlight leaders and innovators who have shaped the past, present, and future of industry. I'm your host, Dr. Leeanne Aguilar. Today's guest is Michael Choate, president of Solutions Press and author of the new book, Silicon Trenches. With decades of experience in product development, technical support, and leadership, Mike has a proven track record of solving tough problems in the pre-AI computing age, and now he's turning his expertise into publishing and futuristic AI robot fiction. Mike, welcome to the show.
Hi, thank you.
I'm glad to have you. Mike, you've had experience on both sides of the help desk. What advice would you give to professionals, both those seeking help and those providing it, to improve effectiveness?
A good question. I worked as a knowledge expert on a help desk for a microcomputer manufacturer before the age of automatic call answering systems. Later, I managed tech support and internal systems engineering teams. Customers or a field service team could call the phone support help desk direct number and speak with an expert. Everyone called us the customer hotline. Experts answered the phone by pressing **3 on our personal landline phone keypad, which transferred the incoming call to our personal desk phone. Each expert analyzed the trouble, recommended resolution steps, and followed up to ensure the problem was resolved. If it wasn't, we automatically escalated the call and provided feedback to management and, if necessary, to our design team to prevent problems from happening on the next revision of the product. Today, most call centers use voice recognition to validate the caller's account and reason for calling before routing them to a support agent. Often, callers are instructed via an automated system to try resetting their equipment first. While this approach increases efficiency, it can also be frustrating for customers, especially if their needs don't fit neatly within predefined options. And that's why I call these no-help desks. First, we need to review how call centers operate. Primary goal: call centers aim to resolve calls quickly and justify their operational cost. High personnel turnover and training expenses contribute to this focus. Scripted support: to reduce training costs and minimize errors, support agents follow prepared scripts or call flowcharts. These scripts require callers to answer a series of questions. Agents use responses to match answers with the script and suggest solutions or the next steps. Caller challenges: most callers haven't gathered all the information that the script expects, leading to delays and repeat calls. Many give up out of frustration if their issue isn't resolved promptly. Feedback gap: there is little incentive for callers to provide feedback, positive or negative, after a support interaction, which makes it harder to improve service quality. Inconsistent support: callers who phone back might speak to a different agent, which can lead to repeated explanations and lost context. Script limitations: scripts often can't handle exceptions and may force agents to provide some sort of generic or mismatched solution, potentially leading to poor outcomes. Agents are typically measured by how many tickets they close, not necessarily by the quality of the resolution.
Right.
These issues can result in a cycle of unresolved problems and negative online reviews. Despite all these challenges, modern call center technology offers several benefits. AI-powered systems can verify accounts quickly and reduce wait times. Some call centers will provide personalized support through chatbots or proactive outreach, enhancing the customer experience, and options such as live chat or callback requests are becoming more common, which I really like. And to improve both customer and agent experience, I recommend the following. Call centers should regularly review unresolved tickets and escalate cases to identify gaps in their scripts and update them based on real-world feedback and recurring issues. Agents should be empowered and incentivized to help customers fully resolve their issues, not just close quickly. When a script does not address a problem, agents should escalate calls to a higher level expert or manager. Call centers might consider additional support options such as scheduled callbacks or live chat for complex concerns. That actually happened to me yesterday for
Really?
an airline flight I had to change. Script creators should incorporate feedback from both call escalation and customer reviews to continually improve the support process. And for people seeking help calling the help desk, I recommend these following tips. Gather as much relevant information as possible before calling to streamline the support process, such as model numbers, brief history of any changes leading up to the problem, screenshots of error messages, etc., and use specific technology related to your problem so the help desk agent will understand better and do it. And you can also do a quick web search to see if anyone else has had similar problems. And
Right. Yeah.
As a last resort, don't hesitate to use the magic words. Escalate my trouble ticket to the level 3 tech support or a management. Lastly, using AI recognition has limitations, such as not understanding every way people describe their issues. So just press 0 and reach a live agent directly, and you'll get the support you need more efficiently.
Yeah, those are great tips. It can get very frustrating when you have an issue. I've experienced this many times where I just want to talk to somebody live, right? So yeah, typically that 0 will get you there. But it can be frustrating trying to get to the right person who can help you, going through the AI system and then being redirected several times to finally get to the right party. So those are good tips. Can you share an example of a support call where you experienced poor quality support and how it was resolved eventually?
Yeah, about 20 years ago, actually a little bit over 20 years ago, I experienced issues when I was exercising some employee stock options, and they were withholding incorrect funds after my year-to-date income had exceeded, the Social Security tax withholding maximum. I called my financial institution, and the support agent looked at my account and said there were no issues found with the transactions and suggested I contact my employer payroll department. The payroll department also said there was no issues, and this went on for a couple of years.
Years. Wow.
Finally, I remembered, it went on for at least 2 years. Finally, I remembered how some of my customers on the help desk reacted to a no help situation, and so I called again, but this time I told the agent that I had called numerous times before over a 2-year period, and this time I had proof that their accounting system had a design flaw, and I was not going to go away until I could talk to a knowledge expert on these transactions. I was transferred to a knowledgeable employee named Eric, and I explained the issue, and he listened. And I showed him the proof that I had, and he looked at my account, and he put me on hold. About 15 minutes later, he came back on and said, I was right. Over $2,000 had been withheld incorrectly for the stock exercise transactions for Social Security tax withholding, and he credited my account for the missing money plus interest. And I asked for and received a written formal letter explaining the issue that they found and the fix. And then later, I exercised more stock options and confirmed that the issue was fixed. And a copy of the letter was included in my book.
Yeah. Wow. Just knowing who to talk to, asking for the right person, I think is essential. And I mean, that's a huge outcome, right? I mean, a lot of money was at stake. And if you're not your own advocate, I think at times, and asking to speak to the right person, pushing the issue, you'll just be rerouted to people who can't help, who don't have the power or the knowledge to resolve those issues, and it can get very
it was
frustrating.
like an exception to the script. They didn't expect this kind of problem to ever happen.
Right. Yeah, and I think it's probably the 80-20 rule, where 80% of the time the script works just great, and people get their problems resolved accordingly. But there's that 20% of the time where someone else needs to step in, where the issue is above the level or of the basic customer service scripts that are provided, and that's where it gets frustrating. Yeah. And so over the years, what were some of the innovative processes you employed to improve how you and your team handled trouble calls from customers?
Yeah, so one of the frustrating things on the help desk is sometimes I would have to put the customer on hold and go look up something like, a part number or some details about the product. And whenever there was situations where I would have the same kind of question asked over and over, my customers, I found it easier to memorize the information, to memorize like part numbers, like 14-digit part numbers, and other important technical details about the design. And I realized after doing some research that the human brain memory cells function as a rapid associative pattern matching or image storage and recall system. And therefore, I customized the steps I would use to memorize things using 4 steps. I would first visualize the word, number, or sound and practice recall. It's kind of like remembering a name. You just say it silently over and over to yourself. And then I would assign a mental label or phrase to that. And then I would prioritize the memory for future recall, like setting an alarm to go off in the future whenever that information would become useful, might be useful. And I would use this to even like when I would set my keys down in a different place in the house where I normally don't set it, so that I would just, tell myself to remember next time I'm looking for my keys, this is where I put it. And so I've never lost my car keys, forgotten appointments, or lost my phone, since I use this in everyday situations also.
Yeah. So you trained yourself how to improve your memory, and with that system of pattern recognition and
that made my customer experience or working on the hotline much better for the customers, because they didn't have to be put on hold while I looked up the information.
Right. You just had it easily accessible right from your memory.
Yeah. And, the other thing is number 2, when a caller comes in, they're kind of, nervous, they're kind of panicked. They're worried that they're not going to be able to get to the right agent. So I would reassure the caller that I will help them, or I would find somebody who can. And then I also found that to make the call go smoother, no surprises, I would kind of survey the customer's knowledge and figure out, what level of knowledge do they have, because some people think they know everything.
Yeah.
And some people are just complete novices with hardly any technical knowledge.
Right.
And I liked working with the people with a little bit of experience or a complete novice a little bit better, because they listen very well and they can follow step 1, 2, 3, and 4 just exactly the way I told them. But the know-it-all, you can't tell them anything.
A lot of resistance because they already know it, right?
Yeah.
Then it's like, well, why are you calling if you already know it?
And sometimes they'll argue with me or not tell me what they already did prior to calling, just to kind of keep me off balance. So, if you get somebody off balance, it's easier to compel them to do something you want them to do.
Yeah, right. So curious, did you also train your teams this memory or the memory technique that you described earlier?
I try to. Everybody's different. Everybody has a slightly different, way of memorizing, and if they're already used to knowing, how to go look up the information, because many times the calls are all, almost every call is different, but sometimes they're the same. Unless there was a really good incentive for them to memorize, it was hard to get them to do that. But I have encouraged them to try memorizing, but not everybody has that skill.
Right. Okay. Now, I know you've worked deeply in hardware and semiconductor environments. What are some of the challenges modern manufacturers face today concerning quality and reliability?
Yeah, so because the technology is becoming a lot more complex, and with billions of circuits in there now instead of millions that we used to have, so I think the biggest challenge is pre-production validation and testing to ensure the product meets specifications. Secondarily, if you do have a problem out in the field with a customer system, it's very important to have the right resources in the lab to reproduce the failure in the failure analysis lab. And let me elaborate a little bit on these 2 issues. I spent a very large part of my career either directly or indirectly involved with quality and reliability processes. At the system level, this includes everything from software to every single component that's supported by the system in every supported configuration. The reliability of the entire system is really only as strong as the weakest part or weakest component in the system, including attached peripherals. So I want to describe what you would think might be a simple real-life quality issue and the proper way to handle it that can be applied to even more complex systems. Once we sold and supported a high-speed 600 line per minute line printer. It was huge on our server system. It would support, the extra wide multi-part striped zebra paper, if you remember that from
Yes.
the old days.
Mm-hmm.
And I was the designated support engineer for that printer. The printer was manufactured by a third party, and they would install a custom cabinet with our company name and brand on it, and they were required to notify us of all changes to the product regardless of the reason. And any change that affected form, fit, or function, and let me repeat that, form, fit, or function had to be tested and approved before we would start shipping it. One day I received a minor cost reduction notice on one of the components. Due to a lack of testing of this component in a real-life production situation, since it wasn't a form, fit, or function type of change, the cost reduction caused improper printing under certain operating conditions in a customer system. I diagnosed the problem and worked with a third party to modify the component, and it took 3 redesigns to get it right. I ordered the factory to stop shipment of the printers in stock until the printers were fixed. I had to track all the printers ever shipped and replace all of the out-of-spec parts in the field under warranty.
Wow. And how many printers was that?
I don't remember. It wasn't a lot. We caught it pretty early.
Oh, good. Okay. Yeah.
This component was a precision machined metal part and was one of the functional parameters. One of the functional parameters on this machined part was never documented in the written design specifications. I think the original mechanical designers just knew how they wanted it to work, and it was a non-standard proprietary parameter unique to this product, so it was never added to the design specs. So the takeaway on this is that manufacturers need to review all the summary or the supplier change lists, and even products that are made by different departments within the same company. Product acceptance after implementing any change must include real-world quality and performance and stress testing. And in my experience, most companies never budget or fund the resources to ensure all these changes do not degrade form, fit, or function, because customers expect a certain level of quality in the product they buy, especially if the product is key to their business or income stream.
Oh,
And if
absolutely. Yeah.
if something goes wrong, they need an expert to take ownership.
Yeah. Right. And does having like an ISO 9001 certification guarantee that products will never ship with defects?
I wish it was that simple. ISO 9001 certification is voluntary. It guarantees a company documents that that they have a process of data collection, failure analysis, tracking customer complaints, and they can demonstrate measurable results from these processes. It doesn't tell a company how to detect and prevent all types of defects, especially hidden ones. It also does not guarantee that the designers documented all of the parameter tolerances that must be checked in the line printer case. I'll tell you a little story. I was once sent overseas to fix a server system that was rebooting itself for an unknown reason. It was configured with the highest number of memory and expansion cards that our system supported. It's like fully loaded. The 5-volt power supply was a modular design, and each one could supply up to 100 watts, but this system needed 4 of them. The 5-volt output had a factory tolerance of plus or minus 2%. But if one power supply had an unbalanced current load while the system was running the most stressful workloads, safety circuits would detect excessive current, causing the system reset to prevent damage to the power supply. When the system reset itself, I could read the overcurrent status register and confirm my suspicion. And so I fabricated a non-conductive tool on the spot to readjust the power supply regulators while they were running, which is very dangerous because there's
I
a
can
lot of
imagine. Yeah, a lot of current going through.
a lot of
Yes.
current going. I mean, in the
Yeah.
factory, they have a fixture. They individually test each power supply. But when they're all plugged into the system and one is supplying way too much current, it needed all of the power supplies to be more closely tuned to the same voltage to prevent overcurrent. So I readjusted them to a 1% tolerance and the problem went away. And then I submitted a formal engineering change, ECO, request back to the final test procedure and got the tolerances changed to 1%. And it was implemented immediately and we never had the problem again.
Yeah.
And the factory didn't have the ISO 9001 certification yet. It was pending.
Okay. And is that something they went then and integrated into their SOPs when it came to manufacturing?
Yes.
Yeah. So other than instances that come up like that, what are some examples of manufacturing defects that may be caused by Mother Nature that no one could have predicted?
Yeah, that's hard. I mean, they don't teach this kind of stuff at school, right? I mean, you're a professor, so.
Right. Yeah. And here in Texas, these things have happened. Like, look at our grid, what happened a couple of years ago when we had a huge freeze. And, our whole power, grid was disrupted. So these things happen and Mother Nature often is the culprit. So what happens then?
Yeah. So I listed 9 examples of this in my book. In chapter 6, there's a chapter called Who's the Boss? And I was making a point that Mother Nature is the boss because this stuff is not taught in engineering classrooms. And I'll give you 2 specific manufacturing examples where Mother Nature caused havoc. So one time we had a clean room and randomly the yields mysteriously dropped. I collected the failure data and after ruling everything else out, I had an instinctive gut feeling to check for correlation to the weather. Lo and behold, the drop in yield was directly correlated to rainstorms. When the ground was very wet or saturated, low frequency vibrations from the nearby roadway and maybe even thunder coupled into the bedrock and shook an isolated table that was fixed down to bedrock that was used for precision electrical calibration in manufacturing. I borrowed a precision vibration analyzer. It proved that the table was occasionally vibrating beyond tolerances. And there were large potholes in a nearby roadway. And sometimes when the ground was wet and big heavy trucks went by at high speed, they vibrated the ground so hard the table shook. It only happened when the ground was wet because they could conduct vibration easier. The vibration was so small that workers didn't notice. Now, we proved this, and the solution was simple. Just to check if the issue was caused by excessive vibration, and just repeat the calibration after the vibration went away, and that fixed the yield issue.
Okay. Was that here in Texas?
Yes, that was actually in Houston, in Northwest Houston.
Okay, interesting. Because I would think things like that where there's actual seismic activity, would happen more often, perhaps in California or other regions where they do experience regular seismic activity. Those kinds of considerations would have to be part of the design.
Yeah, that's a really good point. I think people take for granted if they've been told by experts, trust the science, right?
Yeah.
that we've isolated it from the building because the building, for people walking around, is a big source of vibration. So if you go all the way down to bedrock, you're going to eliminate the vibration, at least from the building. But
Right.
what if the bedrock is vibrating?
Right, exactly.
And when you're dealing with precision calibrations like these, it's so important to have as little vibration as possible because there's zero tolerance in some of these measurements.
Right.
So I got another example. This one's a little different. This involved the design of a printed wiring board, or PCB, used in a PC system. And we had a customer that was qualifying one of our new parts, one of our new CPUs. It had some advanced technology that made it have higher performance. And our first customer who was trying to adopt it was doing their qualification test for it. And they found out that after 72 hours in a thermal chamber, the system operating at high temperature would start getting memory data corruption.
Oh,
But another brand of CPU they were using did not in the same board. And they asked
interesting.
for our help in diagnosing the root cause. So we put a thermal head on the CPU to see if we could induce the failure, and we could not. So therefore, I had a gut feel that it had to be something else other than the CPU. It's just an indirect thing because the way our CPU worked. And I suspected the root cause was either in the Northbridge chip that sat between the CPU and the memory, or it was in the printed wiring board. So our partner insisted that we send an expert anyway before we figured it out to help them resolve the problem. And their headquarters was in the USA, but their design, manufacturing, and testing center was over in Taiwan. So I sent one of my junior engineers named Juan, and I sent him on his way while I stayed and worked overnight, reproducing and analyzing the error. I fabricated my own little thermal chamber by using a 100-watt portable lamp from my home garage, and I was able to reproduce the problem. I monitored the CPU interface with a protocol analyzer, and I triggered on a compare error, and I confirmed that the read data didn't match the expected data that was written. Whenever two things happened. Number one, the pattern of incorrect data written was during a burst write. Now, the state of the art prior to our new CPU was that when writes were done to memory, they would only write 8 bytes at a time. And on our CPU, we would collect the writes into a buffer, and when the buffer was full, we would do all 64 bytes written at a time. And that was what we call a burst write. And when this data within the data pattern comprised worst case ones and zeros switching, that's when the failure occurred. So I analyzed the layers of the printed circuit board. There's there's layer boards with different copper layers that some for signals and some for power and VSS and ground. And when I looked at it underneath this Northbridge, it's what I would call a Swiss cheese power island effect. And I think I was the first one to come up with that term, Swiss cheese power island. And I think that the Swiss cheese power island starved the Northbridge for current.
Oh, Swiss cheese implying there were holes in it? There are gaps or holes?
Yeah, there's normally holes between the layers. Like if I have a solid layer of what the VSS, in order to connect the power and signals through that, they have to have like a little opening.
Okay.
Where they drill a hole and then they deposit copper in the hole to connect the different layers. They call them through holes. So the keep out region was this gap or this spacing around the hole for tolerance to prevent shorting out. And when the holes were too numerous or too closely spaced together, it would actually restrict the current flowing, especially high-speed current. Is it high-speed switching current?
Yeah.
And so we proved it by getting them to run some experiments by sticking very, very thin solid wires into the hole and then soldering it and then rerunning the test on boards that had been failing. And sure enough, they stopped failing. And then on a phone call with their designers, we had to rearrange the spacing of the holes in the power layers, and they built new boards. It took a few weeks for them to get the new boards and prove it, but that fixed the problem.
So did you fix or find the solution before Juan got to Taiwan?
Well, I found what I suspected was the problem, but we had to discuss it with the designers there.
Yeah. And they still had to test
and talk to their manufacturer. It was very disruptive for them to make a change. I mean, this PC had been in production for a long time. I don't know how long, maybe a year or more. And when we got our new CPU came out, and it was faster and higher performance, and so gave them a big advantage, both on price and performance, to use our CPU instead of the other CPU. And because they were the first one out of the top 10 PC makers in the world to use our branded CPUs, they had a big competitive advantage in the marketplace. And that forced 8 of the other remaining 9 top 10 companies to start looking at our CPU, and they all eventually, you know, started using our CPU, and we
Yeah,
got a
adopted that. Oh, that's
larger
interesting.
market share.
Right.
It was a big thing.
Wow. Right. Yeah. But you brought up a good point of just like the troubleshooting process and being able to replicate an issue, being key to solving a problem and knowing how to identify what could be the source of the error with testing. That's a skill set that I think is it's vital, not only in this type of situation, but across the board. That's, I mean, as you were describing it, I was thinking of website development and solving coding issues as well. Clients will call and say, okay, we have this issue with the website, but unless you can reproduce it, you can't really get to the core of the matter and solve the problem.
That was what I've been doing for, over 50 years, it seems like.
Yeah, just problem solving. Yeah, just knowing what to look for. And you brought up like intuition too, just knowing that, okay, wait, something's not quite right. And it's maybe not the obvious thing, but it doesn't feel right. And just that gut feeling to dig a little deeper or maybe, look at something different, go in a different direction. I
Yeah,
think,
sometimes I'll just, get a voice in my head and say, try this.
yeah,
Sometimes it works.
trust that gut. Yeah. Now, you've hired and led many cross-functional engineering teams. What advice would you give to hiring managers and job seekers looking to succeed in advanced technology product development labs?
Yeah, I had a great reputation for recruiting top talent, and other managers ask me for advice often. By default, resumes of job seekers are manually or automatically screened for specific applicant skill sets, education, or years of experience. However, in my failure analysis labs, which we call the debug lab, the unique debug work that we did was almost always unplanned work. So it was impossible to find somebody with the same experience. I was frustrated depending on HR staff to provide resumes of ideal candidates. Since nobody knew what a debug engineer job was, I upgraded the job titles and descriptions to system design engineer to attract mainstream candidates that were targeting our company anyway.
Mm.
If I described the daily work assignments as impossible problems to solve, nobody would want the job. But if I describe it as the opportunity to help engineer innovative solutions, that matches what most talented engineers desire to accomplish. They want their work to make a difference in the world and be appreciated for it. Even engineers have egos.
Yeah, yeah. Well, right. Wanting to make a contribution, wanting to do something important. And I mean,
Right.
yeah, that's a good point. I mean, how you describe the job, how you frame it is going to do wonders in attracting the right talent.
When I had a job opening, I would spend hours reviewing candidate resumes myself and doing phone interviews. And some of my best hires were college interns and new grads. And my company would also send us to college campuses to talk to students and collect resumes for all types of openings all across the company. And I looked for four very specific things on resumes and phone screens. I looked for a successful track record in academics, like getting awards for technical achievement, challenging prior work experience in academic research or innovative companies, ability to create or apply critical thinking skills to solve puzzles, and they were driven to learn how everything works, like a history of taking apart complex equipment, putting it back together again, and the ability to learn new advanced technology quickly and to think outside the box.
Yeah. Now, when you were interviewing, would you have them do any kind of test as well, or show you hands-on what they could do, or was it all just word of talking?
Well, I would often have one of our systems on my desk, and I would have them point out components that they understood how they worked. And then almost always I would give them a word puzzle or some sort of little puzzle to solve, like a riddle or something like that to solve, to test what their thinking skills are, see how they work through understanding a challenge that you have to think outside the box to solve.
Right. So kind of looking for their approach to solving problems, just their process, like their mental process. And right. Because that is interesting. I mean, especially when you're looking for employees who are innovative, who can move things forward, who think outside the box and think of things that haven't been thought of before, right? How do you really identify that? So it's really characteristics as far as how determined they are, right? How motivated they are, perhaps, to solve problems, examples of how they've shown motivation and problem solving in the past, how dedicated they are to not giving up until they find the solution.
Right.
Yeah, to
The
something.
determination to find the answer and never give up is key.
Yeah.
I really
Right.
focused on that. And also the absence of fear of some challenging assignment or fear of making mistakes, the absence of that, because they're always going to learn something.
Right.
Got to be good.
Right. Yeah. Just a courage to handle hard things, to step into and take it on, even though you don't know the answer yet or haven't done it before. I mean, yeah, I can relate it. Even in the early days of HTML and building websites, I would stay up all night, for hours trying to debug something or, figure out what was going on and just to find the solution. and it was usually successful, but it was, I mean, this is before we had, AI and all of the knowledge out there is on the internet and YouTube videos. Back in the day, it did take a lot longer to solve problems. And I think now you can there's a lot more resources to help you find solutions, or at least know where to start and point you in the right direction a lot of times, which is nice. How can engineering students and professionals at any stage practice and strengthen critical thinking skills?
Yeah, I've been asked this question often by students when I tell them that I look for critical thinking skills in applicants. Previously, I thought some people were just born with it and others didn't, or I thought it might be a trait inspired by some local cultures, because I noticed coworkers in other countries attempting to do the same kind of our work were struggling to figure out how to get started on something they had never seen before. And they could work best if they could just follow some written step-by-step instructions. Even though they seem to have a lot of experience in education, they should have been able to figure it out. But our kind of work that we did typically never came with instructions, because we were the first ones to ever see this problem. Or maybe somebody else had already tried everything else and it couldn't make the problem go away. So we had to invent our own processors, and eventually we designed our own advanced tools to analyze data collected. The old way would just use trial and error, but we had to take a more scientific methodology to collecting the data. And then we also had to be extremely knowledgeable of all the changes that had occurred in the past and all the bugs that had been found and supposedly fixed. Because sometimes they put in a change, but they cause some other problem to show up. So you kind of have to understand what's happened in the past and what other bug fixes that have been applied. So then once you make a list of all possible causes and you systematically rule everything out, then the answer has to be something else, right? And you can spend days or weeks looking at it and doing the same old thing over and over again. You're just going to get the same bad answer.
Right. That's the definition of insanity, right? Doing the same thing over and over again, expecting a different result. Yeah.
So we had a way, the way I did it was I used a passing case, collecting data and comparing it to a failing case, and I would look for the smallest deviation between a passing case and a failing case. And but back to the question about how someone can help practice or develop their own critical thinking abilities. As a youngster, I used to love solving problems in the Highlights magazine. I'm telling my age.
I remember those, yeah.
60 years ago in doctor's office. So I used to enjoy finding hidden faces in the images and taking time to memory tests. And I could usually recall more items than other people, and it helps you practice pattern recognition.
Mm-hmm. Yeah, it's like puzzles, problems. I know the Rubik's Cubes, sometimes people would get really good at solving that. And What about like video games or things the kids do now? I mean, do you think that helps with critical thinking?
In some cases, yeah, but I'm kind of biased towards um, violent video games now. If it's fun and creative, I love that idea for kids. But so many of the games nowadays, it may look innocent, but is actually kind of training someone to do some violence if something happens that you don't like.
Yeah.
So
Right. So it depends on the type of video game. But yeah, there are resources like that or games that do really test your critical thinking by having you solve problems. You know what's really fun? I don't know if you've ever tried one of the escape rooms these days. Those are actually mentally challenging and fun, and they actually can develop teamwork, or collaboration as well. So I think
yeah,
things like that is.
I was always the guy you wanted to be stuck in an elevator with because I would be so calm and take a calm approach to keeping everybody from panicking.
Right, right, yeah. Now you've mentored and developed talent throughout your career. What leadership qualities do you believe make the biggest difference in technical environments?
Yeah, I'll describe a few unique but generic leadership qualities applicable to technical environments. Some I'm very proud of. Others, regrettably, mistakes were made. Technology companies has business up cycles and down cycles. In up cycles, there's sometimes a tremendous pressure from upper management to put in extra work on weekends and late nights, sometimes even overnight. And I always made sure upper management knew the names of individuals on my team that put in extra effort and nominated them for awards or recognition. Um, Loyal employees don't mind sacrificing some of their personal time occasionally, but a leader must recognize the risk of burnout when too many sacrifices have been requested. The leader should also make the same sacrifices to set a good example. Nothing worse than a manager asking his team to do something that he or she won't do.
Mm-hmm.
In down cycles, our periodic merit increases and promotions and our bonuses are sometimes cut or eliminated temporarily, which punishes everyone. I felt high achievers who sacrificed a lot over their prior review period needs to be rewarded. For that reason, I pushed back hard when upper management requested overtime and weekend work when times were tough. And I always granted time off to make up for it. My employees really appreciated it and remained loyal to me and the company. I really became angry when I witnessed any managers getting raises or promotions during these down cycles, or when a
Yeah.
manager would take credit for a breakthrough without crediting the individuals who heroically worked long hours without compensation.
Yeah. Right. I mean, yeah, acknowledging employees. I mean, appreciating them, giving them credit where it's due. And yeah, I really I agree with you too. And that just what you said about leaders being willing to do what they're expecting their team to do, setting the example, setting the bar, is vital too. I mean, team morale is super important just to the sustainability of a company. Keeping them motivated and inspired is crucial to, yeah, just the environment. I mean, to the culture, company culture, and ultimately the success of the company. Because if you have a high rate of turnover, that's going to increase your bottom line, and that's going to impact the quality of your customer service, the quality of the product, because you're constantly having to replace team members with people who are less experienced. So yeah, keeping your team motivated, inspired, and setting that example is paramount, I think.
Yeah. Well,
Yeah.
one of the best things that I think motivates people is when an executive from the corporation would do a walkthrough, right? And tell people, how important their work is and how much they appreciate it. But the thing I hate the most is when an executive comes in and without any warning and starts micromanaging your team. That I could not stand. And I had a reputation for kicking those executives out of my lab because they were interfering with our work.
Right. And it's undermining too, I think, of the leader
Yeah.
of that team if they go in and do that. I mean, it would make more sense if they do a walkthrough, if they identify problems, then for them to note them down and then separately have a meeting with the manager and say, hey, well, I saw this and that. Tell me about this, and get insight into the situation before micromanaging and assuming things, because sometimes there might be reasons why things are a certain way. And instead of just calling them out and demanding change without having information is detrimental.
And your employees need to know you have your back. One time I had to go over my manager's head to our senior vice president to get something done. And he called the vice president and said, you got to do what Mike Choate says. And they did, and it fixed the problem. Sometimes you have to do that. And I actually bet my badge I was right. But it was because one of my employees, it was a PhD from Russia. He had a degree from Russia, and he escaped over the Iron Curtain. And he was working for me, and I had put him in charge of this important project, and he was able to figure out the problem. And the upper manager that didn't want to implement it was because he had his simulations was saying there was no problem. But there was a problem. The simulation was wrong. Mm. And we'd proven that. And so I regret not being able to convince the upper manager that his simulations were bad, because he was so committed to the people that were running those simulations. The product was failing.
Right. Yeah. No, it's like you have to stay humble as a leader too, and realize and being willing to admit when something's not working. And it's better to admit something's not working than waste a lot of time and effort and with failure, right? With something that's failing. Now, tell me about your new book, Silicon Trenches. It dives into problem solving in the pre-AI era. What inspired you to write it, and what do you hope readers take away?
Oh, thanks. This is my book, Silicon Trenches. It's got a picture of a wise old wizard and a crystal ball, and he's using his supernatural powers to let the universe tell him what's wrong with the computer chips. Young coworkers, employees used to look up to me because of my years of experience and reputation for solving difficult problems. And I would tell them stories about how the old technology worked, and people would insist that I write a book. They were so impressed with my ability to recall incredible details and make it relevant to today's technology. When I was managing my teams, I also had a mission to design self-healing computer systems. I was inspired by the fictional chief engineer Geordi LaForge on the Star Trek Next Generation, who would run a level 3 diagnosis and fix the systems on the Enterprise. So I did pioneer advanced testing technology we added to our systems to increase ultimate visibility into system operation for the purposes of diagnosing malfunctions and pinpoint very specific types of instructions that needed to either be adjusted or to be tuned to higher performance. This is the key takeaway out of my book. I want people to take with them. When you're designing advanced technology, sometimes you don't think about how someone downstream might need to go analyze a malfunction of that circuit, because they if you ask them how many bugs they're going to have after it goes into production, they're always going to say 0, because they're not going to know what they don't know. And the wizard thing comes up because people accused me of having supernatural powers to solve problems unbelievably fast. And so I created the cover of this book to represent the use of supernatural powers to deduce the cause of malfunctions. A professor once told me that it's more likely that it's just your experience and kind of having the intuition, recognizing patterns, putting things together, and like the missing link, trying to connect the dots, and is what draws you to come to a realization that something that you don't normally see, or something that's not obvious, is causing the problem.
Yeah, right. And I mean, like we talked about at the beginning, just training your brain to memorize and to recognize patterns, and then that later, benefited you as well in solving bigger problems and knowing where to look. Troubleshooting is big key part of that. Just knowing how to troubleshoot, where to look and solve problems. You're also exploring futuristic AI robot fiction. What excites you most about blending your technical background with creative storytelling?
Okay, I just love figuring out how stuff works and how it can be improved. I think I have a very unique view of things, including societal issues. And so I want to write stories that will lead readers to examine the human condition by contrasting with what different possible futures would look like and or feel like from the perspective of both future human characters and robot intelligent observers as they reflect on what has changed since the year 2030, which we haven't come to yet, but still 5 years away. That's the point at which the story kind of goes back to and reflects on. And I kind of look in my crystal ball and try to figure out what's going to happen with technology and the human experience. Although today, applications are in the process of being developed to solve huge problems with life on Earth now. And I think the future does look very bright and interesting with AI in it.
And what would you say, or what do you see as the biggest opportunities, and risks when it comes to AI's role in industry and daily life?
I'm very concerned about AI being misused to distort reality, violate our privacy, manipulate financial institutions and our money. And I really don't trust government agencies to regulate AI. I'm very concerned about the safety and reliability of our power grids. Compared to space vehicles or public transportation systems, the level of safety and reliability required for public AI systems is microscopic. I think the scale of the rapid race to design and manufacture AI hardware should have been delayed until the microtechnology catches up and is advanced enough to make them compatible with our existing infrastructure. I don't think this is going to end well if energy-saving AI hardware doesn't materialize soon. We could rapidly become overly dependent on AI, and it scares me to think what could happen if AI causes a disastrous power grid meltdown or gets infected with a fast-spreading computer virus that gobbles up the data. Some viruses can actually permanently damage hardware or cause it to catch fire, literally technology ignited.
Oh, wow. Yeah. And there is a rapid race to build all of these huge data centers just to support AI. And it's the development is happening so fast. I think I was talking to somebody yesterday and they were saying within 2 months, every 2 months, it's like basically completely revolutionized and that will just get faster. So every couple of months, there's a big turnover in the amount of information and how things process. And the need for energy is just increasing exponentially. And I mean, I'm also talking to people who are talking about some more sustainable ways of delivering energy. But will it catch up to our need for consuming that energy? And so it will be interesting to see what happens, right, for sure. And you point out valid concerns when it comes to security, regulations, and what happens, right, if there is a virus or something that we can't control. I mean, we saw it happen in a physical virus with COVID, let's say, but what happens if it's a technology virus, a computer virus, right? Any final thoughts on that?
Final thoughts. A lot of people are like scared monitoring people about computers becoming self-aware and trying to exterminate mankind. I'm not worried about that at all.
No, it's just the systems going down, like the danger and the risk in the systems going down. Like you said, something actually catching fire or corruption happening, like a system corruption.
Yeah, we're going to get to a point where our lives highly depend on AI, and it's changing rapidly. So if the machine isn't reliable and it goes down or gives us wrong answers, we've lost our own brain power to solve those problems that AI replaced, we could be thrown back into the Stone Ages kind of.
Right. So an over-dependence on AI. Yeah.
Yeah.
And I mean, I've even seen that to some extent with my students, let's say, their over-dependence on Google for giving answers, solving problems, and not taking the time and effort because it's right there at your fingertips. So instead of thinking about it and problem solving, you just go the easy way, which is looking it up and right. Yeah. So that's counterproductive in that we're not challenging our own brains. We're not developing our own brains.
My first semester of college I had to use a slide rule. We didn't have electronic calculators back then.
Yeah.
So
Yeah, right. It's harder. It's more rewarding to not take shortcuts and develop out brain power, learning the mathematics, and using a slide rule, let's say, instead of just a right computer. But yeah, good point. And so, Michael, thank you so much for joining me today and sharing your journey from engineering, leadership to author, publisher, your insights into problem solving, quality, and the future technology. They're both practical and inspiring. And before we wrap up, how can listeners connect with you to learn more about your work and your new book, Silicon Trenches?
Thank you, Leanne. They can reach out to me on LinkedIn. Go to LinkedIn/in/mchoate or I'm sorry, Choatem, Choatem, or they can reach me by email at CPU Whisperer. That's CPUWHISPERER at MIKECTX.com.
Thank you. So yeah, definitely, if you're listening, check out Mike's new book, Silicon Trenches. And to our audience, thank you for tuning in to Industry Ignited. Until next time, stay bold, stay curious, and keep igniting industry.